This is Computer Science 1213, Introduction to Computing. I'm Chris Rill, the instructor, and this is the worksheet video on class design. This worksheet begins with a graphical summary of a particular class. I'm going to leave that up on the left because all the questions refer to it as we go through it. I especially like the beginning of this worksheet where it says classes and objects are the two main aspects of object-oriented programming. A class creates a new data type where objects are instances of the class or copies. Objects can store data that belong to the object. Objects can also have functionality called methods, which consists of procedures or functions that belong to a class. A UML diagram is a graphical summary of the data and methods in a class. This is a limited part of a UML diagram for the turtle class. So since I have that on the left, I'm going to go ahead and come down here to the questions, and we'll refer to the diagram as we move through it. By the way, the Alice program has a turtle class. The graphic that's shown here are portions of that object's material data from that turtle class. Question 1 says, identify one example of a data field given in the UML diagram for the turtle class. What is the variable name for the data field? So you can see over here on the left, here is a set of pieces of data that pertain to the turtle class. The width and height and depth of the particular turtle that we're dealing with, the color of the turtle, and the opacity, or how much you can see through it. An opacity of 1 is solid and 0 is invisible. What is the variable name of the data field? Well, that's after the word set, whichever one you'd like to pick. Actually, it's with the word set. Set width, set height, set depth, set paint, set opacity are the names of the data field. So you would pick one. What is the data type of the data field? Well, what's the data type when you have a number and you can have numbers to the right of the decimal? You should know that. This one, for failure of another one, would be a string. This is a string orange. So the data type in this one would be a string. These others are all of the same data type, and you should know what that is by now. Number 2, identify an example of a method used from the turtle class. What is the method name? Well, we have some in green here and some in kind of a blue-gray here. For the method, I would probably pick one of these. And this bold lowercase text, generally, except for the T here, is the method name. So you can pick one of those. What arguments does the method take? Well, it's given here. For example, on the first one, move, it wants to know what direction you want to go and how far. The next one, the argument would be what other object do you want to go to and how close do you want to get, or how far away. You could put a negative number in there. And with turn and roll, just like with the move, it wants to know what way, what direction you want to turn and roll and how much. In our last program, or a couple of programs ago, we used a turn, and we turned left or right, and it was 0.25. We had to give it those arguments for it to work. What's the method's return value? How do you know? There is no return value for a procedure. These are procedures. There's no return value. There's nothing to get. These up here are functions, and you would get a piece of information. For example, up here, we can set the width of the turtle to 1, and down here in the midst of the program, we can get the width from that particular turtle, find out how wide it is or how high it is, which we could set up here as well. Within our program, we can get that information. So at these green ones, here's the paint, here's the opacity. These here, the depth. We could set them here and we can get them here. So this will give us information. So the method, if we chose it from down here, would not return a value. But if we used one of these appearance or size items, it would return a value. It would get that information from the object. For each of the methods that we have here, identify whether it modifies a data field. If so, which data field? Well, here's data fields: width, height, depth, paint, opacity. These will not modify a data field. All they do is return the information of what's currently in that data field. These down here will cause the position to change, and so if there's a function for its current position or orientation, it would have an effect on that particular data field. So these methods need arguments, these don't. What happens if an invalid data type is given? Well, the program won't run. You'll get an error. But Alice is real good about preventing that, but Java is not. It'll let you put the wrong thing in, and then your program won't run. And that's one of the reasons we use Alice and not Java. Whether the method will expect arguments that fall within a specific range. Well, there would be a limit. Well, this opacity, for example, goes from 1.0 to 0.0. So if you used a 2, that's not going to work for opacity. When a method did not modify a data field, what did that method do instead? It returned information. All these functions in the green middle area will just return the current state of these particular data fields without changing them. These down here change them. Not necessarily these data fields, but they changed the value of the data. These green ones, these functions, only return what information is currently contained in the data field. So 5, imagine you have a code segment that creates 2 turtle objects, turtle 1 and turtle 2, and moves one turtle to a different location from the other in the same world. Give the syntax for calling the forward method on both these turtles. Have them move forward 100 steps. So if we use this one, this procedure, this turtle moved forward 100. We could do that. Then we would select the other turtle and do the same procedure. The thing is, when you make a new instance of the turtle class, which is a new object, a new turtle object, all the data for that new copy goes with that new object. So it's independent. You have one turtle, has all this different information. When you make another turtle, it has a different set of information. Now it's just the same things in the sense it has a width and a height and a depth and a paint and opacity. But they could have different values. The values of one turtle can be different from the values of the other turtle for the same data fields. Is it possible for two objects to have different values for the same data field? Yes, because all of the data fields for an object go with that object. And when you make another copy of that object, it has a new set of data fields just for that object. So is there a limit to the number of different objects that you can create of the same class? Only in terms of the memory and the memory that you have to work with. Eventually, you won't have enough memory to do it. It says in Model 2, a class can be used to represent objects in the real world, like we do in Alice. When designing a class for the first time, it is often easier to consider an object in the real world because identifying appropriate data fields for real-world objects is more straightforward. That's what we have in Alice. Many of the methods in a class will fall into two categories. Either a mutator, that's methods that are setters, they set the data fields, and that's our procedures down here. These kind of things. And you could look at the full set if you go to Alice and load up a new desert turtle. Or an accessor, which are getters, that get the data fields. That's over here contained in the functions. These get information that's being stored up here in the data fields. It doesn't change the information, it just grabs it so you can do something with it in your program. These down here change the information that's located in the data fields. So identify a mutator method. That's going to be these procedures. Which data field did it set? Well, a position data field. We didn't list one up here, but it'll change a position data field. What arguments did it take? Well, it depends on which one you pick here. 3 of them take a direction and an amount. The other one takes a target, which is another object, and an amount. What does the method return? Nothing. Nothing. It sets a data field, one or more, but it doesn't return anything. Now identify an accessor method from the turtle class. It gets the data fields. Any of these gets here. Which data field did it get? Well, opacity gets the opacity amount, whatever this value happens to be. What arguments did the method take? It didn't need any arguments. It just went and grabbed the current value out of that particular data field. What does it return? Well, it returns the value from the data field. In this case, it returns the value that set opacity has in the data field. And then your program brings it back to this spot. And that concludes the worksheet on class design.